Okay, electrons and bonding. So electrons and shells. You already know that the nuclear atom contains electrons in shells surrounding in the nucleus. In this topic, you will learn more about how electrons are in shells. I think we went through one of the slides and it was somewhat related to this.
Oh, yeah, yeah, yeah.
For GCSE, we
I
learned
remember.
that 288 rule. So we learned this in GCSE, if you remember, 288 rule, which means that 8 and 8 electrons will be in the shells that come up
Yeah.
first one.
I think we can go through this quite quickly.
Yeah,
I think because we've already been through it already,
yeah,
so
yeah.
we don't need to spend too much time on it.
Yeah. So what are shells in atoms? Electron shells make up model that helps us to visualize something that cannot be seen. Shells are regarded as energy levels. You already know that the energy increases as the shell number increases. So the energy increases as shell number increases. So the energy at the outer shells will be, I think we stuck on this point as well. The energy in the outer shell will be greater than the energy that is in the inner shell. The shell numbers or energy level number is called the principal quantum number.
But can you repeat that again?
Yeah, if you remember, you had a problem understanding that the shell that is closest to the nucleus has less energy compared to the shell that is away from the nucleus.
Okay.
So that's why they are saying that they can also be the energy increases as the shell number increases. Shells are regarded as energy levels. The energy increases as the shell. So the shell that is near the nucleus
Yeah.
will have the least energy. So the electrons here will have the least energy, and the electrons that are further away from the nucleus will have more energy.
Okay.
So now, if you think about it like that, I think I used the same example last time as well. If you have to take out this electron from this atom, what do
Yeah.
you need to do? You need to ionize it, right? You need to
Yeah.
maybe hit it with an alpha particle. What
Yeah.
will the alpha particle do? It will transfer energy to this particle, right? It will transfer energy to this particle, and this particle will move further away from the nucleus. If it
Okay.
if it gives energy to this particle that is inside, it will move further away from the nucleus. So that means if you have to go away from the nucleus, you need energy. So anything that is away from the nucleus already has more energy. It's just like gravitational potential energy. If you are flying on in a plane,
Yeah.
and I am just in Sunderland and looking above, and you are just flying
Yeah.
from the top. So, who will have more energy? If you think about it, absolutely, you will have more energy because you have gravitational potential energy. You won't feel that energy, but if someone throws you out of the plane,
No,
you
but don't you have a greater gravitational potential energy because more closer to the
so what's the
you're
formula?
more closer to
If you remember the formula of
the
gravitational
Earth basically.
potential energy, that was mgh. So that is gravitational potential energy. So if the height is greater for someone, it will have more energy. So
Oh yeah.
if I am if you are on the top of the roof and I am just on the bottom floor, obviously you will have more energy. Uh, you know that because if you jump from the top roof, you will break your bone. But
Oh yeah.
if I just drop like this on the floor, I won't hurt myself because I did not have that much energy to be able to break my bone. So
Yeah.
so anything that is further away from the center,
But I thought if you like go so no, let's say in atoms,
yeah,
the shell that is so let's say francium. Wait, I need to see a periodic table. I think in group one is the one at the bottom, francium.
I don't remember.
Okay, wait, I can check. Okay, so in group one, the top one is lithium,
Yeah,
and the one at the bottom is francium. So
okay,
francium has more of those electron shells.
yeah,
So the one electron on the outer shell is further away from the nucleus
yeah, yeah,
than lithium.
yeah,
And francium since the one is further away, the electron is further away, it needs less energy to get rid of it.
Yeah, yeah, because it already has that energy. The electron in the outer shell, it already has that energy. It just needs a slight push so it can get away from the atom.
Oh, yeah,
The
yeah,
ones
I
that
get
are
it.
the ones that are closer to the nucleus, they need a lot of energy to get out. So the one that is just about to fall anyway. So it does it just
Oh yeah, yeah, I get it.
it already has the required energy. It just needs a slight push. So the thing that is closer to the nucleus has less energy. That's why they are saying the energy increases as the shell number increases, because these ones, they already have that energy. They already have a lot of energy. They just need slightly more to be able to leave it. So that's why the energy levels increase as the shell number increases. Does that make sense?
Yeah.
All right. The shell number or energy level number is called the principal quantum number. So the shell number or the energy level number is also called the principal quantum number. So
Yeah.
I think we went through this as well. Do we need to go through these small notes or something? Electrons in shells. The current,
Uh, if it's A level stuff, then we'll go through it.
yeah. So let's just go through it quickly. The current model for an electron is based the idea that an electron has properties both of a wave and a particle wave. Particle wave, particle duality. If you take A level physics, you will learn more about wave particle duality. Current model for electron has a property.
Okay, I guess I might
I
learn about this then.
yeah
I'm gonna take up A level physics.
yeah. So yes, so what they are saying here is that the electrons has property of both wave and particle. So wave has different properties and a particle has different properties. But they're saying that electrons has the properties of both. So wave particle duality. If you take A level physics, you will learn more about wave particle duality. Around an atom, electrons can only fit into energy levels defined by the wave nature of an electron. The maximum number of electrons in a shell n is given by the formula number of electrons equal to 2n squared. Use the 2n squared formula to check the number of electrons in table 1. Find out the maximum. So you don't need to go into detail here, but they are just saying that electrons behave like particle as well as a wave. Just like light is sometimes considered to be a particle and sometimes it is considered to be a wave. So, so other than that, I think there is nothing important for now in this section.
Yeah.
So, atomic orbital. Shells are made up of atomic orbitals, and an atomic orbital is a region around the nucleus that can hold up to two electrons with opposite spins. All right. Now it's getting slightly interesting. Shells are made up of atomic orbitals. An atomic orbital is a region around the nucleus that can hold up to two electrons with opposite spins. So if you see, all the electrons mostly are in the form of pairs. So those pairs are now called the atom. Whenever if we, even if when we draw the uh, all right, so shells are made up of atomic orbitals, and atomic orbital is a region around the nucleus that can hold up to two electrons with opposite spins. So, so basically, so if even if you think about it, this is a nucleus, this is the principal quantum shell, this is the second principal quantum shell. If you think about it, we always thought that we always, whenever we made these kind of quantum shells, we always made it like this, two electrons together like this.
Oh yeah.
So these two electrons are said to be, so shells. These are shells. This is shell one. This is shell two. Shells are made up of atomic orbitals. These are small atomic orbitals. An atomic orbital is a region around the nucleus that can hold up to two electrons. Now, these can hold two electrons, and both of these electrons have opposite spin. If this one is rotating like this, the other one is rotating in the other direction. That is what it means.
Yeah.
Models visualize an atomic orbital as a region in space where there is a high probability of finding an electron. So, models visualize an atomic orbital. So, this is how they define it as a region in space where there is a high probability of finding an electron. So wherever you see that there is a high probability of finding an electron, that is called the atomic orbital. So figure one, an atomic orbital shown as a cluster of dots for the probability of finding an electron in a given space. So wherever you see the dots are very close to each other, we say that there's a high probability of finding atomic orbital at that point around the nucleus. All right. So it's
Yeah.
theoretical. It does not have anything very complicated so far. So atomic orbital is can only hold two electrons. Atomic orbital has those electrons rotating, orbiting or rotating uh, with opposite spins. So they have opposite spins. And models visualize an atomic orbital as a region in space where there is a high probability of finding an electron. And the other definition of atomic orbital is the space around the nucleus where there is high probability of finding electron. And if you see, these dots are very close to each other when they are near the nucleus. Obviously, if you go uh, away from the nucleus, obviously the probability of finding electrons will be less, right? And when
Yeah, yeah, yeah.
so that is what it means. Electron can be thought of a negative charge cloud with the shape of the orbital referred to as an electron cloud. So an electron can be thought of as a negative charge cloud with the shape of the orbital referred to as an electron cloud. So the shape of orbital can be referred to as an electron cloud.
Okay.
Totally theoretical, nothing
Yeah, yeah.
very complicated. An orbital can hold one or two electrons, but no more. So an orbital can hold one or two. So there is an option of one as well, just because of something like nitrogen. So it has two electrons in the in the inner quantum shell, and in the second shell, I think it has five electrons. So one of them is alone. It does not have it is not in an orbit that has two electrons. So that's why
Yeah.
an orbital can hold one or two electrons, but no more. So it can also have one electron. So this is also an orbital, but
So an orbital is like the SPD and F. Is that
SPD,
an orbital?
there are different types of orbitals. SPD, yes, 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 yes,
Yeah.
yeah.
So it's one S and then it's one S and then two S.
Then two S, yes, then
Yeah, then two D.
two P.
No, two P and then two D.
No,
Yeah,
there's
it's
no 2D.
SPD.
There's no 2D. There, I think there's 3D or 4D, but no 2D. Because in this two, one, two, three, it represents the quantum shell. So in the second shell, this is the second shell, it
Yeah.
cannot contain more than eight electrons, and S can accommodate. So 2S will be I don't know if you write it here, 2S2.
Yeah, 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 you write it like
Accommodate
that.
two electrons, and P can accommodate six electrons, not more.
Oh, okay.
So there can't be D because
Yeah, then there won't be.
yeah, I think it's we have
Three has D, I think.
yeah, I think we have 3D, yes.
But I think 4S fills up before 3D.
Yeah,
Is that true?
I think there is something like that. I think we'll come across something maybe in this topic that actually tells why that is or how it
Oh
is.
yeah.
I also need to go through it myself. So there are different types of orbitals, S, P, D, and F orbitals. Each type of orbital has a different shape. So S orbital. In an S orbital, the electron cloud is within the shape of a sphere. So S orbital is said to be the electron cloud is within the shape of a sphere. So that whole electron cloud, the space where the two electrons are, is contained by a shape of a sphere. As with all orbitals, an S orbital can hold one or two electrons. So it can hold one or it can hold two electrons. Each shell from N is equal to each shell from N is equal to 1 contains one S orbital. So each shell from each shell from N is equal to 1 contains one S orbital. So each shell from N is equal to 1, I think means N is equal to 1 means first shell, first principal quantum shell.
Yeah, yeah, yeah.
The greater the shell number n, the greater the radius of its orbital. So of
Yeah,
its s
I
orbital.
get
So
it. Yeah.
yeah. So if it's shell 2, shell 3, shell 4, their s orbital will be slightly different. They will have a greater radius of the s orbital. So the
Yeah.
s orbital will not be the same for all of the principal quantum shell. They will
Yeah.
have different radius depending on which quantum shell it is. P orbitals. In a p orbital, the electron cloud is within the shape of a dumbbell. So so this looks like a dumbbell. No, I don't know if it looks like that or not. As with an s orbital, one orbital can contain one or two electrons. Okay. There are three separate p orbitals at right angles to one another. So if you see, just like an s orbital, a p orbital can also have one or two electrons, not more than that. But there are three separate p orbitals at right angles to one another. So if you see this one, this is along the x-axis, the other one is along the y-axis, the third one is along the z-axis. So there are
So all of this is P,
all of this is just a single.
but would they be like together?
Yes, they will be together and they'll make something
Okay.
like I don't know, a star or something.
Oh yeah.
So yeah, so there are three separate p orbitals at right angles to one another. These orbitals are referred to as px, py, and pz. Each shell from n is equal to 2 contains 3 p orbitals. So we know that quantum shell 2 has a p 3 p orbitals because it can have 8 electrons. So 2 are in s and 3 sorry 6 are in p. So px has 2, py has 2, pz. So this is the
Wait, what
maximum.
do you mean 6 R?
So
Oh, 6 are in P, yeah.
yeah, 6 are in
Yeah,
p.
yeah, yeah.
That's the maximum number. The greater the shell number, the further the p orbital is from the nucleus. So we already know it will be yeah further away. All right. D orbitals and f orbitals. The next orbitals d and f orbitals are more complex. Each shell from n is equal to 3 contains 5 d orbitals. So 5 times 3. All right. Sorry, 5. 5 times 2 is 10. Yeah, so d can have 10 electrons in total. Right? That is what it
Yeah,
means.
yeah.
5d orbitals, so it means each can have two because no orbital can have more than two. So 5d orbital means that it can have a total of 10 electrons max. F orbital, there are 7 F orbitals in quantum shell, starting from quantum shell 4. So 7 times 2 is 14. So 14 is the maximum number. All right.
So the principal quantum shell 4
Yeah.
can hold 14 plus 10
Yeah.
plus 6 plus 2 electrons.
Yeah. Yeah. Yeah.
Okay.
Yeah, that's the maximum number. But I think the thing that you were saying, we'll come to that later, how they are organized. So first, do we fill S? First, do we fill P? We'll see
Oh, yeah, yeah.
later. So subshells. You may have noticed that a new type of orbital is added for each additional shell. Uh, when a shell within a shell, orbitals of the same type are grouped together as subshells. The orbitals and subshells in the first four shells are shown in the table. So shell number one, we have just one S. So subshells present just one S. Number of electrons two, number of electrons in shell two. Shell two, we have one S orbital and three P orbitals. So subshells that are present are 2S and a 2P. So S and P are the subshells. Uh, I think the whole P with its three orbitals is called just a single subshell, is what I'm getting, right? This is what I'm getting. So
Okay.
a P, so P has three orbitals. So there are three P orbitals, Px, Py, Pz. If you combine them, that is just one subshell.
That's just P.
That's just P, and that's just one subshell. Three,
Okay, yeah, yeah.
three orbitals, and that is just one subshell.
So the subshells are just S, P, and D.
Yes, I think that is what they mean.
Okay.
Yeah,
So
orbital.
would we need to like
Uh,
specify?
yeah, they're saying it here. So if you see, orbitals of the same type are grouped together as subshells. So orbitals of the same type means all p's, all d's, all f. So they're
Yeah, so S, P, D, and F are all subshells.
subshells. Yes.
So will we need to specify which electrons are in which P, which orbital of P?
No, I don't think so. No. No.
Okay, that's
I
good.
don't think so. You need to do that, but let's see if it comes up. But I don't think you need to say that it's in PX or PY or PZ. I think
Okay, that's good.
it's the case. Each new shell gains a new type of orbital. So each shell gains a new type of orbital. The number of orbitals increases with each type of, sorry, the number of orbitals increases with each new type of orbital. So S, 1, P, T5, F7. Yeah, so each new shell gains a new type of orbital. Yes, okay. So new type of orbital means that the previous one had a P, the new one, the third shell will have a D orbital as well. The number of orbitals increases with each new type of orbital. The number of orbitals increase. Obviously, with each new type of orbital, the number of orbitals increase because S has just one orbital, P has three orbitals, D subshell has five orbitals, and F has seven orbitals. So the number of orbitals also increase in a subshell as we uh, continue to move forward. Two electrons fit into each orbital. So the number of electrons in each subshell also increases.
Yeah.
Electrons fit into each other, so the number of electrons in each subshell also increase. Yes, so 2, 6, 10, 14. We know that already. All right, so
Okay.
the subshells that make up shells have slightly different energy levels within each shell. The new type of subshell added has a higher energy level. For example, in the second shell, the 2p subshell is the new type and is at a higher energy level than the 2s subshell. So I think you get the point that uh, if two subshells are in one of the shells, then P, for example, will have a higher energy level than S out of those two. So
Yeah.
in N equal to 2 shell, the order of filling is 2s, 2p because as we saw before that the lower energy subshell will be filled first and then the higher energy subshell will be filled after that. So if we talk about N is equal to 2, which is the second shell, the order of filling is that first S will be filled and then P. In the third shell, the order of filling is that first S, then P, and then D. In the fourth one, it's S, P, D, and F. So F is the one that will be filled last.
Yeah.
Figure 4 shows
Does D have 5 orbitals again?
S had
S has
one,
1.
P had
P had 3.
P,
So it's
D
6
had
altogether.
D
D
had
I think had 5.
D I think had five. Let me see. So
Because altogether it can have 10 electrons.
yes, P has
So I think it has 5.
the next orbitals contains okay 5 in D and F has 7.
Yeah.
So total 10 electrons can be in D subshell and total 14 electrons can be in F subshell,
Yeah.
right? And each orbital can only have two. You already know the
Yeah. Yeah.
maximum number is two. Okay. Figure 4 shows the relative energy levels of the subshells making up the first four shells. So the first four shells, how they are arranged in terms of energy are shown in figure 4. The highest energy level in the third shell overlaps with the lowest energy level in the fourth shell. Now, the highest energy level in the third shell, which is 3D, where is it? The highest energy level in the third shell overlaps with the lowest energy level in the fourth shell. So 4s comes slightly down in the energy level compared to 3D. 3D
Yeah.
has
Yeah.
higher energy than 4s. So that actually means that 4s will be filled first, then 3D will be filled after that.
So why didn't the scientists just call 4s 3D if it comes first?
Why didn't they call 4s?
So 4s, they
Come.
should have just called it 3D.
Um, I'm not sure how the subshells are named. For example, uh, okay, if you think about it, I think that the shells, they are also their different energy levels on average. So maybe 4s is slightly in the outer zone. So the radius of 4s, I mean the fourth shell is greater than the radius of the diameter of the third shell. So 4s will be, I think 4s will be uh, far further from the nucleus as compared to uh, 3D. So 3D will be in the inner region of the atom compared to the fourth one. So that's why it's called 4s and not 3D. That is what I think. Now, why 4s has lower energy? Because what we know is as far as you go from the nucleus, the energy increases. But they have put 4s before 3D, so there must be some reason. Now we know that 4s should be in a higher energy level state. We know that it should be in shell 4, which was also called before as, what were they calling shells?
Uh,
Energy levels or some quantum number, the shell number or energy level.
principal, yeah.
So energy level number. So energy level number for 4s is greater than the 3D, right? But still it has less energy. So I don't know why is that. So there must be some other reason behind it as well.
I think it's different for transition metals.
Maybe, maybe
I think I heard something like this. Can you check? So, is this for normal atoms? 4s fills before
it
3D.
I think it is the same for all of them. But
Uh, I think for transition metals it might be different. I heard something like this. I
uh,
think from one of my teachers might have said it.
so what we will do is we'll just go through it right now and just try to
Okay.
Google it later. Just
Yeah.
see if there's any significance of this with the transition metals. Now, when it comes to N3 and N4, we already know that these two should be these are period 3 and period 4. So they are not at the top of the periodic table. These things are at the bottom part. Not the bottom, but in the middle somewhere. So I don't know
Yeah.
what transition metals are. I think they are in the center of the
Yeah,
period.
yeah, then the middle.
So yeah, maybe it has something to do with that. I am not completely sure, but okay, let's see what's maybe they have written it after this. But what I know is that 4 actually depicts the energy level of this whole shell. So 4s, it seems, should be at higher energy level than anything from energy level 3 or shell 3. But 4s, they say overlaps 3D. So when they say overlap, it may be that both of them have almost the same energy because 3D is very close to 4s. Because they did
Yeah.
not say that 3D has greater energy than 4s. If you look here, they said the highest energy level in the third shell overlaps with the lowest energy level in the fourth shell. So it means that both 4s and 3D have exactly the same energy. So what happens is first 4s is filled because it is an S. So it's always, if you think about it, always we fill first S, then P, then D. So if D and S both are at the same energy level, S will be filled first. So that is the most uh, logical explanation I can give. So
Okay.
because both of them overlap in the energy, so S will be filled first and then D.
So does 2s have more energy than 3s?
2S has less energy than
Or
3S.
I mean less energy.
Yes, definitely, because it's
Yeah, yeah.
shell 2 overall has less energy than shell 3. But what happens is that uh, as we go up, like 2s, then 2p, so 2p will have higher energy than 2s. I think
Okay.
we went through this as well.
So
Within
as they go up, as
yeah,
they go
yeah,
like higher, they have more energy.
yes, if you see here, within each shell, the new type of subshell added has a higher energy. So
Okay.
2p has higher energy than 2s, but there will be a significant difference between 2p and 3s. That's why 2p is still has less energy than 3s. That's why 2p is filled first, then 3s. But as you go into the shell 3, 3d has almost the same energy as 4s, which is the first subshell of shell 4. So if they have the same energy, then S will be filled first and then D. That is
Yeah.
possible reasoning of this. And they did not use the word that 4s has greater energy. Sorry, 3D has greater energy than 4s. They said that the highest energy level in the third shell overlaps with the lowest energy level in the fourth shell. That means they have almost the same energy like this. So in that
Yeah.
case, S will be filled first, then D. I think that's the best explanation to this. So
Yeah.
always lower energy shells are filled first. Lower energy subshells are filled first, then the higher energy subshells. And when it comes to that two subshells have the same energy, we first fill S, then P, then D, then F, if they have the same energy. So
Yeah.
that's the reasoning for that. Okay, the 3D subshell is at higher energy level than the 4S subshell. So, okay, now they're saying not overlap, but 3D has a higher energy level than 4S. Okay, the 4S subshell therefore fills before the 3D subshell. The order of filling is therefore 3P, 4S, 3D. So for now, just keep this in mind that we first fill 4S then 3D because 4S may have slightly less energy than 3D. Yeah, so we fill 4S first and then 3D.
Yeah.
So what they said before was that if you go shell 1 from shell 2, shell 3, shell 4, the energy level increases. But these are the extremes of their own shell. So 3D is the extreme highest energy point of shell 3, and 4S is the lowest energy point of shell 4. So it there is kind of an overlap there because of that. So
Yeah.
keep this in mind. Electrons pair with opposite spins. Each orbital can hold up to two electrons, we already know. Rather than drawing different orbital shapes, it is convenient to use an electron in box model. So it's an electron in box model on the left, I think. Electrons are negatively charged and repel one another. So the things that we need to keep in mind. So they are negatively charged and repel each other. All right. Electrons have a property called spin, either up or down. So we just saw before that orbitals, the two electrons in each orbital have different spins. So one will be pointing towards the top and the other one will be pointing towards the bottom. It depicts
Yeah.
that they have different spins. Electron is shown as an arrow indicating its spin either up or down. The two electrons in an orbital must have opposite spins, as shown in figure 5. The opposite spins help to counteract the repulsion between the negative charges of the two electrons. So because of this counter movement, they overcome their repulsion and stay together.
Yeah.
So I think I have been through this before myself as well, and they at that time I thought of what could be the possible reason of them not repelling each other. So um, I don't remember exactly right now, but it has to do something with the spin. Because of the spin, there is some kind of counter force that is produced, and that
Okay.
counteracts to cancel the effect of that repulsion. So they stay together. So maybe
The up and down spin.
so they spin like this. One spins like this, the other spins like that.
Oh, but
So
in the diagram you do it as a up and down.
yeah, in diagram they have shown it as up and down, which just depicts that one is rotating like this and the other one is rotating like this.
Oh yeah.
So yeah, so because of that move, all right. So the electron is spinning because of the spin. I think because of this, so it has something to do with the. Uh, I think in GCSE you went through uh, induction. So was it current induction or was it so if a charge moves through something, a magnetic field is produced or something like that, if you remember. Flux, if you remember flux or something related.
Oh, something like this.
Yeah, yeah.
I
So
forgot what it was.
because of the spin, I think Because of
Fleming's left-hand rule.
yes, Fleming's left-hand rule. I think that was it. So it has something to do with that. Because of that, there is some kind of opposite force produced that counteracts the force of repulsion, and they just stay together because of that.
Yeah.
So I think I need to think about it, but it's very easy. I know that I thought about it before as well. All right, so we'll just move on for now. So orbitals with the same energy are occupied singly first. So within a subshell, the orbitals have the same energy. One electron occupies each orbital before pairing starts. Okay. Within a subshell, the orbitals have the same energy. One electron occupies each orbital before pairing starts. This prevents any repulsion between paired electrons until there is no further orbital available at the same energy level. What they are trying to say is, for example, you have 2p. So 2p has px, py, and pz, right? So there are
Yeah.
p orbitals. So what happens is that first the electron goes into px, then the electron goes into py. It does not complete px. Then the third electron goes to pz. So P, so after that, all of the orbitals are occupied by a single electron. Now,
Yeah.
then the fourth electron will go to px again, and there will be two electrons.
Oh yeah, the downspin then.
Yeah. So that is
So how do they know if it's downspin or not?
um
So like um so if it's upspin, then they can go into separate ones. But how is the next one down? Like what even is downspin in reality?
so these arrows, if you're talking about the arrows, they just represent
Yeah.
what kind of spin it is. Is it clockwise or is it anti-clockwise? So I think the up one, if you use the right hand rule, will mean that it's, if you see from the top, it is anti-clockwise. For the down one, if you see from the top, it is clockwise. So I think the arrows just represent if it is clockwise or anti-clockwise, if you see it from the top. It's not up or
Okay.
down, I think. Yes. So whatever goes in first, the other one has to rotate in the other way. That is what I.
Yeah.
So within a subshell, the orbitals have the same energy. One electron occupies each orbital before pairing starts. This prevents any repulsion between paired electrons until there is no further orbital available at the same energy level. So they don't occupy the same orbitals at first. They occupy different orbitals. Then when there's no space left, then when then the electron go into the one that already has one electron. So with four
Yeah.
electrons, one electron occupies each p orbital. With four electrons, yes. So how many electrons can p? So p can only have six electrons, right? So with four electrons, one electron occupies each p orbit. So one electron. One electron occupies each p orbital. Only then can pairing take place. The paired electrons have opposite spins. So first, the electron will go into the first, which is px. Then an electron will go into the second, that is py. Then an electron will go into pz. And after that, this down arrow electron.
Then will come, yeah.
Yeah. So that is how it happens. All right. Electron configuration. An electron configuration of atoms. For A level, you are expected to be able to work out the electron configuration of atoms up to atomic number Z is equal to 36. So you are uh, expected to work out the electron configuration of atoms up to atomic number 36. If you look at atomic number 36, it means that uh, till how many shells? So they have already done it for you here. So 36 means 36 electrons. So 1 s 2 s 2p, 3 s 3p, 4 s 3d, and 4p. So 4p is the maximum number you will go in A levels. You won't go
Okay.
to D here or F.
Yeah, we won't see F at all.
Yes. At end of the period 4 in the period. So this is the end of period 4 in the periodic table. Period.
So we need to memorize up until atom number 36,
Yes.
krypton.
Yes, and you don't even need to memorize it. You already know the sequence, how the electrons will be filled. 1s, 2s, 2p, 3s, 3p. After 3p, 4s, then 3d, and then you go to 4p.
Yeah.
Because if you just memorize this, you don't need to. If you just if you just memorize this pattern, you don't need to memorize anything else. You can.
Yeah. Wait, so the P had three of those like dumbbells that they said. One was PX, which was a dumbbell, and then another dumbbell, PY,
Why?
and then PZ, which is another dumbbell.
Yes.
What was D again?
They did not tell you anything about D, how it is placed. What they
Okay.
told you about D is that it has five orbits. That's
So
it.
they didn't say like if
No,
it's DX or
no,
DY.
no.
Okay.
That is not part of the course, I guess. So the only thing you know about is the shape of S and P. That's it. For D and F,
Yeah.
you only know how
Wait,
many.
what was S again?
S was a sphere, I think. Yeah, it's just a sphere.
Oh, just a sphere.
Yes. So it can occupy two electrons. All right. And just memorize this. You don't even need to memorize this. You just know in first you just have
Yeah.
S, in second you have S and P, in third you have S, P, and D. But you also know that D has higher energy than 4S. So 4S will be filled first, then 3D, and after that 4D. So just keep this.
Yeah.
The 4S subshell fills before the 3D subshell because 4S has a lower energy level. Now they have contradicted with their own saying before. So they said that these are energy levels 1, 2, 3, and 4. And higher
Yeah.
higher will be the energy. But now they are saying that the last subshell of 3 has slightly higher energy than the first subshell of 4. So this is just
Yeah.
a
Yeah.
contradiction in what they have said before. So you just need to keep it in mind. We don't know what is the science behind it. We don't need to know. So I think that should be fine.
Yeah. Yeah.
So the electron configuration of krypton is therefore written as, so you can always write it like this. And uh, maybe the last one, okay, P also has complete electrons. So all of them have complete electrons till P. So P can occupy a maximum of 6. So yeah, that's that. Even if you go below krypton, let's say 35. I don't know what 35 is, atomic number 35, whatever it is, then P will have just 5 electrons and not 6.
Yeah.
Does that make sense?
Yes.
All right. So figure 7 shows the meaning of the numbers in an electron configuration using, and that's, I think that's why the iPad will come handy if I'm able to edit the videos on that. So it will come handy doing that. Uh,
Oh, yeah. Yeah.
so figure 7 shows the meaning of the numbers in an electron configuration using nitrogen as an example. So where is figure 7? So figure 7, I think you can do it yourself. Now it's very easy for you to be able to uh, write the electron configuration of anything, right? Okay, I think you now know how to do the electron configuration of anything. I think whatever comes in the exam, you can do it easily.
Yeah.
Are you confident that you can do it
Yeah.
yourself? It's just that whatever comes first, just fill it first.
Yeah. I can do one practice question just to check.
Yeah. Do you want to do it now?
So shall I do one for,
Yeah, just do atomic
yeah.
number
Just
30.
give me any element
Not 30.
for 30.
No, no, not 30. Um, maybe just do um,
Oxygen or something. I don't know.
just do atomic number 19. I don't know what it is. Just
19.
yeah.
Okay. So 1s2, 2s2, 2p6, 3s. So is this right? 1s2, 2s2, 2p6, 3s2, 3p6, 4s1.
Yeah, I think that's fine. So you know how
Okay.
to do it right now, so that's fine.
Or
All
did
right.
you just know it in your head?
Yeah, I can see this 1s2 s2p written over here, so I knew that you will end here at 4s.
Okay.
So I already knew. All right. So the 4s subshell fills, all right, we already know this. Figure 7 shows, okay. Table 4 shows the electron configuration of the elements across period 2 of the periodic table together with much simpler electron structure from GCSE showing shells only. I think you're fine with this, so we'll just move forward. Short
Yeah.
electron configuration. Now, what is short? Electron configurations can be expressed more simply in terms of the previous noble gas in the periodic table plus the outer electron subshells. Table 5 shows this shorthand notation for elements in group 1 of the periodic table. This notation is useful for emphasizing similarities in the electron configuration of the outer shells. So what they are saying is that shorthand notation will be helium. So for example, you have lithium. We know that we have hydrogen, then helium, then lithium. So lithium is very close to the closest to the it's closest to helium, which is the noble gas. So the closest noble gas to lithium is helium. And whatever is helium, lithium has just one more electron. So they just wrote helium like this and then just 2s1. That's it. Similarly,
Yeah.
sodium is the closest to neon. So neon comes before sodium, just one electron before sodium. So that means atomic number of sodium, whatever it is, just one less from it will be the atomic number of neon. So that's why they just write Ne and then 3s1. That's it. Because 1s2, 2s2, 2p6 is the electron configuration of neon. So they just skip it and they just write Ne and then just 3s1 with it. So whatever, so you
Okay.
whenever they
But
say
it's not actually neon. Like
it's
it isn't like actually neon.
so it's actually neon plus 3s1, which is actually sodium.
Yeah, but it's not like neon isn't present.
Neon is not there. It's
Yeah.
just to write it in a shortcut. So you just instead of
Okay.
writing 1s1, 2s2, sorry, 1s2, 2s2, 2p6, you just write any because everybody they are assuming everybody knows that any and just after one electron,
Okay.
3s1
Yeah.
sodium. So
Yeah.
so what you have to do is you have to look for you, so for example you are at potassium. So you have to go back the so uh, potassium. I think these are very easy. So if so, what comes after potassium?
Um,
Can you look at the periodic table? What is after potassium?
rubidium. Oh no, calcium.
Calcium. So it's calcium. So whatever. So what we will do? We will go one. We will first go one atomic number below calcium. What is that? That's potassium, right? And it's not
Yeah.
a noble gas. We will keep on going until we get the noble gas. So what is before potassium?
Argon.
Yes, argon. So that means calcium has just two more electrons than argon. So we can just write Ar like this. And we definitely know that Ar will have complete 8 electrons in its outer shell. So we will have 4s2. So we can write in a shorthand notation like this Ar, then 4s2. You can do it for any one of them. So any element you get, you can write like this for that.
Yeah,
So
yeah, I get it.
for example, if you have what is after calcium?
Scandium.
What's the symbol for that?
Sc.
Sc. So that means Sc has three more electrons than argon, right? Now this is where I'm a bit confused. So what's the atomic number of argon itself?
The atomic number is 18.
Atomic number is 18. All right, that's fine. That's fine. So, okay. So what do you think will be for scandium? How will I write it in shorthand notation?
So you do argon, so
Yeah,
Ar,
yeah,
which is 18,
yes.
and then scandium has 21. So
Three more.
wait, so 8 to 3 more, so 4s3.
So S is one orbital. It just has one orbital to it, so it can only occupy
Oh,
two
four,
electrons.
no, oh yeah, yeah. I mean 4s2
Yeah.
and 3d1.
Yes. Yes. That's the correct way to write it. All right.
Yeah.
So now you get the point. You can write it in any way. So you have enough knowledge about this. So okay. So electron configuration of ions. So positive ions or cations are formed when atoms lose electrons. Negative ions or anions are formed when atoms gain electron. You already know what is cation and anion. Blocks and the periodic table. The periodic table can be divided into blocks corresponding to their highest energy subshell. So periodic table can be divided into blocks corresponding to their highest energy subshell. Okay. S block.
Isn't this what we already learned, the SP and DNF?
Yes, that's the same as PDNF.
Okay.
But now in periodic table, by looking at where the element is, you can tell which is its highest energy subshell.
Okay.
Just by looking at it, you can tell now. So S block will be the one that is just at the start. So I think the first two groups will be all S block, I think. Highest
Yeah.
energy in the S subshell, left block of two groups. You know why it's left block of two groups, right? Because they have just one electron in group one in their outer shell and two
Wait,
electrons
what does it mean left block of two groups? I don't
uh,
get it.
left block of two groups. So it's the leftmost block out of all the blocks that are in the periodic table. So S block is the leftmost block of the periodic table and it comprises two groups,
Oh, so what do you mean the left of the periodic table, like group one?
group one and group two. Two groups. S
So
block
group one and group two have, wait,
group
I'm
one and
confused.
group two. So your periodic table can be divided into different blocks. All right. First thing is that your
Okay.
periodic table can be divided into different blocks. Those blocks can tell you what is the highest energy level subshell that they have. That's the thing.
So
Now
does S block, what's the highest energy subshell?
the S subshell is their highest energy subshell. Now
Wait.
we don't know if it is if it is 1s or 2s or 3s or 4s. We don't know that.
Okay.
It can be any one of them. What we will know from these blocks is that if the highest energy subshell is S subshell, whether it's 1s, 2s, 3s, we don't know that. Or if it is P subshell, whether it is 2p, 3p, 4p, we don't know that. So it will just tell you what is the highest energy subshell. Is it S? Is it P? Is it D? That's it.
Okay.
Does that make sense?
So group one and group two,
Yeah.
they end in S. So the
All of
last
them. And
electron will be in an S.
yes, if you think about
The
it, yeah,
yeah.
yeah. If you think
Yeah.
even what does group one mean? What does this
It
group
has one
one?
electron in its outer
Yes,
shell.
yes. So if if there is just only one electron in its outer shell, which subshell would it be in?
Wait, I don't get this.
So if the outermost shell, whatever the outermost shell, if it is shell one, if it is shell two, if it is shell three, it only has one electron in it. So what subshell would it be? Would it be P? Would it be D? Would it be S?
But there can be one in D, there can be one in anything,
No,
can't there?
no.
Can
So
there only be one electron in S?
if if you think about it, uh, if you think about it, what do we know about group one? That it has one electron in its outer shell, right? So
Yeah.
if you think how we write it, we always write like this. We fill 1s first, we then fill 2s, then we fill 2p, then we fill 3s, then we fill 3p, then we fill, I think, 4s, then we fill 3d, and so on, right? Something like this.
Yeah.
So Now they're saying there's only one electron in the outer shell for group one. You already know this. So either that will be shell number one, which is their outer shell, like in the case of what's the first element in group one? Like hydrogen. Hydrogen, is it considered to be in group one?
It's a bit of a
Yeah,
mixed one.
yeah.
Lithium.
Hydrogen, helium, lithium. Yeah. So yeah. Okay, okay. I think that we don't consider hydrogen in group one. It's considered in some other group. I don't know what it is. But
Yeah.
if you think about lithium, for example, so what is the subshell, the highest energy subshell for lithium? Think about it. It has atomic number three. So what will be the highest energy sub
So it will be 2s
2s? All right. What will be the highest energy subshell for what is after lithium in group one?
sodium.
Sodium has atomic number of what?
11.
11. So two here, I think six here. So this is how many? 10,
10.
one
And
here.
then yeah, 1.
The highest energy level, again S, right? If you keep on
Yeah.
going like this, it will still be S. So that's why the first two groups are called S block, because their highest energy levels are always S, no matter if they are 1s, 2s, 3s, but they will be S. Does that make sense?
Okay. But what if something is like an ion?
So they did not talk about ions so far.
Okay.
Yeah, but for ions, you know what will happen. If they were not ions, then it will be like this. But if,
Yeah.
for example, like sodium, for example, sodium has one electron in its outer shell, and that is in 3s. If they lose that, then their outer shell will be 2p6 in that case, and not 3s.
Yeah.
But we are not talking about the ions right now. We are talking about uh, neutral elements, those who have the same number of electrons as their atomic number. So all of the group one and group two so all of the group one and group two are the highest energy level for them will always be an S subshell, right? No matter whichever shell it will be always S subshell. Does that make sense?
Yeah.
And that's why group one and group 2 accumulatively they are called S block. Then you will have a P block here, and then maybe you will have a D block here or something like that. Does that make sense? Why they're called S
Yeah.
block? Because
Yeah.
the outer, yeah.
No, the D block are all transition metals.
All right. So now you know what S block is, right? So P block. So highest energy electron in the P subshell, right block of six groups. So it's the right block of six groups. So I think it will be three, four, five, six.
Yeah, like all the noble gases, halogens,
Yeah,
and all of those
yeah.
around there.
Then the D block is highest energy electron in the D subshell. So center block of,
I think transition metals.
yes, these are transition metals, you were right. So ions of S block and P block elements. When forming ions, the highest energy subshell lose or gain electron, as I told you about sodium. Table 6
Yeah.
compares the electron configurations of calcium and oxygen atoms and their common ions. So if you see calcium is like this. It's in S block, so it has 4s2 at the end. What happens to calcium 2 positive? It just loses its outer subshell. Now the outer subshell is 3p instead of 4s. Two electrons lost from 4s subshell. Does that make sense?
Yeah.
Whereas oxygen, it gains two electrons. So previously it had 3p4. Now still it has p as the outer subshell, but it has six electrons now. So maybe, it's six electrons instead of four now. But the
Yeah.
subshell is the same. Does that make sense?
Yeah.
So ions of D block elements. For atoms of D block elements, the 4s subshell is at a lower energy than the 3d subshell. So it is filled first. So first 4s is filled. We already know first 4s will be filled if it is gaining electrons, then 3d will be filled. The energies of the 4s and 3d subshells are very close together, and once filled, the 3d energy level falls below the 4s energy level. All right. The energies of the 4s and 3d subshell are very close to each other. We already know that. That's why 4s was filled first. Once filled, so once 4s is filled, the 3D energy level falls below 4s energy level. The consequence is that the 4s subshell fills before the 3D subshell. So we already know that the 4s subshell also empties before the 3D subshell as well. So 4s empties before 3D subshell as well.
Yeah.
So it's the same. So nothing is different here. The D block element, nickel, which is Z is equal to 28. So atomic number is equal to 28, forms the ion Ni2 positive. So it loses two electrons, and it is the D block.
Wait, the 4s empties before. So if it loses an electron, it will lose from 4s, not 3D.
No, it will lose from 4s because 4s is the highest energy level right now. Wait. Yeah, so that is what they were saying here, which I
That's a bit
yeah,
confusing.
yeah, that is what they are saying here. If you read this, the energies of the 4s and 3D subshell are very close together. All right. So once both of them are filled, once filled, the 3D energy level falls below the 4s energy level. So so what happens is when they are not filled, when you are actually filling them, then it is something like this: 1s, 2s, 2p, 3s, 3p, then 4s, and then 3d. So this is how you fill it. But once they are filled, it's no longer like this. It's like 1s, 2s, 2p, 3s, 3p, and 3d. When it is filled, it comes below 4s. Now 4s is at higher energy level than 3d. So once it is filled, it comes down. So 3p, 3d, and then 4s. Now, whenever it will lose electrons, it will lose from 4s and not 3d.
Wait, what if 3D is not filled, but it has some let's say if it has one electron, but it's not filled.
Mhm. Once filled, the 3D energy level falls below. Yeah, that is something that I don't know. So, how many electrons can D occupy? D can
6.
occupy 10 electrons.
Oh, yeah, 10 I meant.
It's not filled completely. It's still not filled completely. So I think even it has one electron in it, it will be below in energy level than 4s because still it's not filled completely, and they have treated it like this. So 4s is at high.
So the 4s only comes off. Wait, oh, I'm confused.
So just remember this is how
Why
you
is
fill
the
it.
3D before the 4s?
Why is 3D before the 4s?
Yeah,
Because when you have filled 4s, you fill 3d, right? So
yeah.
this is the sequence how you fill it. As soon as you have put even one electron in 3d, now it all comes into how it should.
Order.
Yeah, so 3d comes before, and 4s is now at a higher energy level.
And then when it needs to lose an electron,
Yes, so
will it lose from 3D or from
4s
4s?
from 4s, because now 4s is at higher energy level because 3d of
That that doesn't make sense at all.
it does not need to make sense. You just need to know this.
So no. I think I'm not. That's confusing. So let's say if it's like all filled up until 4s,
Yeah,
and then one electron goes into 3D.
yeah,
Like one electron is in 3D,
yeah,
and let's say if it then 3D comes before 4s, and now 4s is the outer
yes,
one, is
yes,
the highest one.
yes, yes,
So then what if it needs to lose one electron?
yeah.
Will it lose the one electron from the 3D, or will it lose the one electron from the 4s?
4s. You will lose one electron from 4s.
Okay.
Yeah. We have to keep this in mind because there's no logical explanation that is on this stage. I have not went through it. I in my engineering was not in chemical, so I
Oh
don't know.
yeah.
I don't know even those guys know this. Only the chemist will know this if he knows, provided that if he knows. But I think you just have to uh, accept this. So
Okay.
as soon
So
as
then, but then that doesn't make sense though, because then the 3D will be partially full and then the 4s will be partially full as well.
4s will, yes, you're right.
Because then, so let's say the 4s is filled and then one electron is in 3D. So
Yeah.
if it wants to lose one electron, the easiest thing would be just to lose the one electron from 3D. Why 4s?
So again, I have no answer
Yeah.
to that, but
Because then 3D has one electron and 4s is already a filled. It's
Mhm.
filled because it has two.
Yeah,
But then that will have one as well.
yeah. So both of them will be not completely filled, right?
Then would the one electron from the 3D will it shift to 4s?
That is a very good question, but I don't think they will answer it, and I don't know.
No, wait, do you get my question
Yeah,
though?
I do get your question. I know that you are saying both are partially filled now. So
So
4s
then would
and
the one electron from
yeah,
the 3D would it go to the 4s and then 3D would disappear?
it should happen that way, but I'm not sure if it does.
Okay.
Yeah,
I need to ask this to my teacher.
do ask him and let me know as well.
Okay.
So, okay, let me just try to quickly Google it if something Google Google has to say.
It will be hard to even search such
Uh,
a question.
uh, it was nickel. What happens to electron configuration of nickel when it loses one electron? That is no, that is not your question. That is not your question. Your question will be something that has two electrons in 4s and one electron in 3D. What would that be? What would that element be?
Uh,
So, uh, so 1s2 and then 2s2 and 2p6 and 3s2 and
21.
3p21,
21,
3p6,
I
4s2
think.
and 3d1.
I
So how
think
much
21.
is it? So 10 and then 18 and then 20 and 21. So it's 21. So what is
Yeah.
21? Can you see the atomic number? What is 21?
Scandium.
Scandium. It's already a scandal in scandium. So I don't know what it does. What happens to scandium? What happens to electron configuration of scandium when it loses just one electron? Does scandium lose again? What happens to electron configuration as you move? We already know the order of filling. The order of filling, we already know this. So 4s is filled first. Everything is straightforward. All right. So D block elements. Yeah. So where is the flaw in the logic? The solution. How to argon. There's no problem with D. The general pattern that we do in the diagram. The pattern is still working. The 4s orbital has lower energy than 3D, and so forth, but the entirely fits with it. Okay. Why is not electron configuration of why is electron not electronic configuration of cadmium E3 rather than 3D14? Okay, we already know. Imagine you build okay. Making scandium. Okay, this one. You might expect the next electron to go into a lower energy 3D orbital as well to give 3D2, but it does not. You have something else to think about here as well. If you add another electron to any atom, you are bound to increase the amount of repulsion. Repulsion raises the energy of the system, making it less energetically stable. It obviously helps if the effect can be kept to a minimum. The 3D orbitals are quite compactly arranged around the nucleus. Introducing a second electron into a 3D orbital produces more repulsion than if the next electron went into the 4s orbital. There is not a very big gap between the energies of 3D and 4s. The reduction in repulsion more than compensates for the energy needed to the
So
energetically
what does that all of
more
that mean?
stable structure for SC plus is this.
Here.
Okay. So yeah, so again, the answer says don't overthink it. Just
Okay.
when they say take one electron out, you have to take it out from the highest energy subshell. And we know when we have filled it, 4s will be the highest energy subshell after filling it. When we were filling it, we will fill electrons first in 4s, then 3d, right? That was the
Yeah.
way to
But
do.
when you even put one electron in 3D, then 4s is higher.
Yes. Then 4s
Okay.
becomes a higher. Okay. Now, if you want to remove one electron, you will remove one electron from 4s, obviously, because it is the one at the highest energy. Now, your question was, why doesn't this electron go back into 3D and we just omit 4s? Or why the electron from 3D does not come back to 4s and we completely omit 3D? That was your question, right?
Yeah.
So they are saying, don't overthink it because it will stay like that. The reason is that the reason is the same as we went through. So first, for example, like first we fill px with one electron, then py with one electron, then pz with one electron. Why? Because we want to keep them as separate from each other as possible. Now, when it comes to fourth electron, then we again put that fourth electron in px, but it has opposite spin, and that's why it overcomes the repulsion. Now, the thing is that we want to keep them as separate from each other as possible. So we just keep one electron in 4s and one in 3d so that both are not in the same and we don't want to deal with that repulsion thing again. So just keep it like that. That is what they are saying. One electron
Okay,
in
so you
3D.
just don't do anything else.
No, you just keep one
Okay.
electron in 4s and one in 3d. Why? To avoid that spinning effect and avoid that repulsion. So to keep them as far from each other as possible.
Yeah.
That's why I keep them in different subshells. Does that make sense?
Yes.
Okay. All right. Let's go back. I did not know we will find it that quickly.
Yeah.
So somebody also thought of it like you. Okay. So yeah, I think we are done with this one.